Talk about some more examples. Okay, so what does this code do? What is this code? What function is it?
Checks if C is not equal to Y, or sorry, checks if C is equal to Y, or C is equal to capital Y,
Mm-hmm.
and then not so.
Okay. So we return unless the value of C is either lower or uppercase Y. You know? So perhaps this might be a little bit clearer. If C is neither lowercase y or uppercase y, then return. It's not so clear here. It is better. But sometimes it's easier to write reason about and. So, if neither lowercase y or uppercase y return. This is more of an idiom. In other words, it's a more common way to kind of put it for whatever reason. But it's also a little bit confusing, maybe a little bit easier to understand. Okay, how about this? How can we improve that? What does this do? Okay. Okay. So there's an if statement might be a way to improve. What is this computed? What comes out of what is the length that comes out of this? The value that comes out of this expression on the right is being assigned to this variable length. What is it assigned? Okay. So whichever is smaller, either length or buff size, is sort of what comes out of that. If length is smaller than buff size, then it's length. If it's buff size is smaller, it's going to be buff size, right? So we could have a length expression, but even better, ladies and gentlemen, would be to use a method or a function. So we say a function minimum. And you could take the minimum of length above. Now in this case, the minimum is a commonly supported function in C libraries, and so it's readily available for us. How many people feel that this is clearer than that original expression? Okay. I will tell you, you see this a huge amount, especially in code from people like you. And I mean, if there's a function that already does it conceptually, if you say length is equal to the minimum of its current value of size, there's a function that already does it. I mean, use that function. It's going to be much clearer conceptually about what's going on here, what you're trying to do. And that's a lot of what we're doing here. I try to motivate this discussion of programming style, ladies and gentlemen, by talking about the complexity of software and the fact that lives like yours are sometimes ruined because software projects get canceled. You have to go find it. I can see it lives. It's not like you go into the spiral of doom and you're sucked into a vortex for the rest of your life. But careers are unnecessarily shortchanged. People lose their job because the project fails because it can't get out into work. It can't make the customer happy with the first version of the product. These are very real things. And complexity has a lot to do with it. Something like this is much clearer than this thing above. Now, the next statement of that, folks, is, folks, you are computer scientists. Sit up, straighten your chairs. You folks are computer scientists. You have dignity, and you have power in your hands. Ladies and gentlemen, you don't have to depend on the gracious character of the creator of C libraries. You don't have to depend on your professor to magnanimously provide you with functions and otherwise give recourse to expressions like the one above, or even worse, like this one here. You don't need to do that, ladies and gentlemen. Instead, you can write your own functions. Let me make that statement again. You can write your own functions, and you should be thinking about what functions stuff I write that would simplify my code. You know, maybe you see the same expression again and again and again in your code. Maybe it's this expression here. Maybe it's an expression like this. This leap year. Where's our leap year? It's back there a bit. Maybe it's something like this. Maybe you keep on seeing a comparison like this. You could create a function which computes that and then just call it. And you don't have to look at that stuff. Just take that complexity, stick it in a function, then you just call the function and it does its work. Then, if you listed it out, you know, it's got an if statement in it and so on. And why have to look at it if you don't have to? The same thing you should be thinking all the time about your code. It's like, what could I carve out? What could I, as we say, abstract here so that I could just reuse it many, many places and it would clean things up. This is one of the most important principles, and it's easy to do. It's very, very easy to just sit down and write an expression like that. So write an argument, create one. Maybe there's max, maybe there's non-max. Doesn't matter. You can go create it really quickly, and then you can make your code a lot cleaner. You can clean it up. And chances are you may be able to reuse min or max or whatever your thing that you compute in other projects. So you got a triple win. Please, folks, think about this. Put a big emphasis on this. So with problem set 1, which I'll hand to you next week, it's no exaggeration to say that a lot of the battle is just thinking a little bit for a little bit. What would be the right way to carve this up in terms of if I created a function to do one thing or do another? You know, here's a lot of repeated code. If you see repeated coding, ladies and gentlemen, it's just crying for you to put it into a function, just call it twice. Instead of repeating it twice, you call it. Single function, a few different places. There's only one place to fix the code. If you find a bug in it, you only fix it one place instead of fixing it 2 places or 10 places. And it has a clear name that you can relate to so you know what it means when you see it. You're more likely to say, oh, okay, I know what that's doing. And you don't have to look at it unless you want to, because you carved it out and put it off somewhere else. Simplify your thinking, simplify the thinking of other people. This, too, ladies and gentlemen, is part of being dignified with your code. Sort of identifying these places. Come to view repetition in your code and kind of just lots of sort of code there as being assigned something's wrong. It's a bad smell, and if your kitchen is a bad smell, a bathroom is a bad smell, you put the time to cleaning it up, clean up here. The good thing is, we could, we're computer scientists, we could like conjure up a mop like that. It's like, okay, Mr. Clean, got in here, go to work. And then once we do that, we'll have a spanking new bathroom we can use, and we'll be able to do that all throughout the future. Weird analogy. Okay. Okay, so carving out, so this is called